Hi, I'm Zach Portman, and I'll be talking to you today about the importance of vouchering specimens. So first off, what is a voucher? Essentially, it is a specimen and the associated data that have been permanently deposited in a collection or museum. And vouchering is especially important for monitoring because without an accurate view of the past, you can't compare the present, and monitoring requires consistent identifications over time. And there's two main reasons to voucher specimens. First, it allows you to fix errors and misidentifications. And second, it allows you to update identifications when the taxonomy changes. And just more broadly, vouchering specimens allows replication and verification, which are cornerstones of the scientific process. And the way I see it, vouchered specimens kind of forms a pyramid uh, with specimens forming the base, and then the taxonomy and the data are built on top of that. And if you have a properly preserved and labeled specimen, you can always go back and fix the taxonomy and data. So to show one example, this is a specimen that was collected by Catherine Reed in 1992. It was misidentified as Protandrina parvis by LaBerge, and then a few years ago it was correctly identified as Protandrina pauper by Joel Gardner. And then this was used in our upcoming Bees of Minnesota paper and provided a unique county record. And because we had a vouchered specimen, we can go back and fix it. And without a voucher, this record would be permanently wrong or unknowable. And vouchers are also important for when the taxonomy is updated, which I think is not appreciated by many non-taxonomists. For example, we recently split Andrena ziziae into two species, Andrena ziziae and Andrena vernalis. And as a result, all existing Andrena ziziae need to be checked and have their taxonomy and data updated. And these types of taxonomic changes are happening constantly. Just one recent example, the red-tailed lazy glossum were revised by Gardner and Gibbs in 2020. The number of species in that group increased from 17 to 35. And this means that essentially all red-tailed lazy glossum need to be re-identified because the taxonomy has changed so substantially. Um, and taxonomic changes are happening constantly, and there's many groups that have not been revised in many years, including Melissodes, Nomadas, Ficodes, Osmia, and taxonomic changes will be coming to these groups. It's just a matter of time. Um, and so you need voucher specimens to fix these down the line, and if you don't have a specimen, you can't fix the taxonomy when it changes, and you can't update the data. So I want to go into a couple examples of how this affects bee monitoring and you using some real world examples using GBIF data, which is the Global Biodiversity Information Facility, which is essentially a giant public repository of biodiversity data. So this is the county level distribution of lazy glossum versatum in our upcoming Bees in Minnesota manuscript. Counties highlighted in green represent counties with confirmed museum specimens. Now here's the map updated with GBIF data. Counties in orange represent records from GBIF, but there are no museum specimens from those counties that I've been able to confirm. And in the GBIF data, there are 1,387 records from these 9 western counties. And this is odd because we've heavily sampled in these counties, and I would classify lazy glossum versatum as uncommon or rare in western Minnesota. And as it turns out, I've been able to find and check only 18 of those lazy glossum versatum, and all 18 were misidentified. And digging into this specific issue was one of the big reasons I decided not to use any GBIF data for the Bees of Minnesota project, and we only use museum specimens we were able to personally confirm. And so for the second example, I downloaded all publicly available bee specimen data for the US from GBIF. And I focused on all the bee data since the year 2000, which is nearly 1 million specimens. And so the top data source by a long shot is the USGS Bee Inventory and Monitoring Lab with about 450,000 records. And to look at this another way, here's just a graph of all the US bee specimen records since 2000. And now superimposed on top of that in red is the proportion from the Bee Inventory and Monitoring Lab, which is about half of the data. And now here's the bee inventory and monitoring data set on its own. And so I'm going to delve into the bee inventory and monitoring lab data to demonstrate how there are taxonomic artifacts that can only be fixed by going back and checking vouchered specimens. So just this is a example of a typical species, Lazy-glossum crisonii, which hasn't undergone any taxonomic changes yet. And as you can see, it's collected fairly consistently over time. And this next species is Lazy-glossum gotham. And you'll notice it has a big jump in specimens around the year 2011. So what happened? Did Lazy-glossum gotham increase in abundance or expand its range? And actually, Lazy-glossum gotham was newly described in 2011 by Jason Gibbs. And this demonstrates how Lazy-glossum gotham is showing up essentially only once it's been described. And so just a quick review, in 2010 and 2011, Jason Gibbs heavily revised the Lazy-glossum subgenus Dialictus. He described 30 new species, changed the taxonomy and identification of many others, and he estimated that roughly a quarter of previously identified specimens were misidentified. And as a result, many species need to be rechecked, and there are many examples of species showing up in the data only after they have been described or their identification clarified. So for example, Lazy-glossum ephialtum was described in 2010. Lazy-glossum leucocomum was reinstated in 2010. Lazy-glossum trigeminum described in 2011. Lazy-glossum hitchensi, which had its identification clarified in 2010. And then some of the problems are a lot more subtle. For example, Lazy-glossum pilosum was split into 3 species in Gibbs 2010. And if you look at the data, it looks like there is some kind of drop-off potentially around that time. But really the only way to know what's going on is to go back and check the specimens. And this is important because so much bee data is from Lazy-glossum. And that genus makes up about 31% of the bee inventory and monitoring lab data set. And as you can see, many records were identified using different criteria before Gibbs revised the subgenus. And that means all specimens from around 2010 or earlier should be re-identified. But it's not just Lazy-glossum. Here's an example, Ceratina strenua. This one has had stable taxonomy, so it's been consistent over time. But Ceratina mcmackii was described by Rehan and Sheffield in 2011. And similarly, Ceratina dupla had its taxonomy clarified in 2011 as well. And then finally, we have a more recent example, Agochloropsis ferigula, which we reinstated in 2022. And it looks like it may be on the same track of showing up in the data only after it's been clarified. So how can you fix this? Essentially, you need to go back and recheck all the specimens. But in these examples, that is not possible because the bee inventory and monitoring lab throws away the majority of its specimens. It's estimated that they destroy 75%, give away 25%, and save around 2%. And this means that the problems are unfixable and the data is not appropriate for monitoring because you cannot go back and make the identifications consistent over time. So it's impossible to tell whether the changes are due to taxonomic artifacts, misidentifications, or real changes. And just looping back to the GBIF data, this means that a huge swath of publicly available records are not useful for monitoring because the specimens have not been identified using consistent criteria over time and they cannot be fixed. And unfortunately, it's difficult to filter out these records on GBIF because they're still listed as preserved specimens, even though they've been destroyed. The bee inventory monitoring lab has declined to change their status, and GBIF does not see this as an issue because the specimens were preserved specimens at the time they were identified, even though they were subsequently destroyed. And so what are the solutions to this big problem? Essentially, you need to preserve the specimens for the long term, employ taxonomists to identify specimens and update old material, and maintain and update specimen databases. And the answer is natural history museums and insect collections. So I recommend everyone who is collecting specimens should partner with natural history museums. For example, all the specimens we collect are deposited in the University of Minnesota Insect Collection. Um, these collections are declining, they employ fewer people, but there are many still around. They need funding and support, and they're generally very happy to work with people and organizations. And also, if you're using data that someone else collected, be sure to ask questions about the data, especially whether the specimens have been vouchered, whether they're in a museum, whether they were identified by a taxonomist, whether there have been any taxonomic changes in the group, and whether there's a plan to check and update specimens over time. And so the final takeaway is if you don't preserve the specimens, they aren't useful for monitoring because they cannot be updated or verified. And hopefully we can have some good discussions on this point.